right, number 6. So, we're at a point where we're going to be comparing key features. You're going to find in math that you're going to be comparing key features a lot. So this time it's for linear equations like straight lines, but we're going to learn about all different types of lines, not just straight lines. And you're always going to have to compare key features, so this is one of those that's going to show up again and again and again. So, time to learn it good. So first of all, a key feature is something special in the situation, right? So we have tons of key features. So for example, some key features that tells us something special is the slope, because the slope's what we're changing by, or the y-intercept, right? How much you start with. That's very special and important to us, right? It's also important to us the x-intercept, where it's crossing the x-axis. I'm going to explain why that's important in a minute. But also, it's important to us if the graph is increasing or decreasing. Like, are we getting stuff or losing stuff? So that also matters. Increasing / decreasing. So these are all of our key features. And first, I'm going to remind us, this whole first page is a reminder. I'm going to remind us how to figure out in each one, in a situation, an equation, a table, and a graph, how to find each of these 4 things. Because these are the 4 ways we do math, in either situations, equations, tables, or graphs. And so we need to be able to figure out the key features in all of them. So, that's where we'll begin. And then later on, we'll compare them. Because the whole point is to be able to compare them, but first we have to figure them out. So, and I've already taught you how to figure them out, but I'm just going to remind you. So, for situation, if you remember, slope is, I wish I could see it all at once. Let's see. What if I put it to 90? Can you see the whole thing? Better, okay. Okay. So, in a situation, to figure out your slope, it's how much you are getting or losing each time. So your slope is how much you're changing by. In an equation, and y equals mx plus b, slope is the m. That's where slope is, because it's always with x. Slope is always with x in an equation. In a table, if you remember, it ended up being, you had to take the change in x, y, like how much your y is changing, over the change in x. Meaning, you take the second, one of your second y's minus the first one of your second x's minus your first x. And you can pick any point in the table to be the first one or the second one. But that's how you calculate it. And on a graph, if you remember, we use slope triangles. So, if we had a graph and a line, we found 2 points. And we made a little slope triangle. And remember, it's still the change in y on top over the change in x when you do the calculation. All right, so that's how you figure out slope. Increasing and decreasing is based on slope. So if your slope is positive, if you're getting stuff, then you're increasing, you're going up. Because increasing means going up. So increasing is if you're getting stuff. And it'd be decreasing if you're losing stuff. Meaning in an equation, it's increasing if m is positive. Because if it's a positive slope, that means you're going up. And it'd be decreasing if m is negative. Because that means you'd be losing stuff and it'd be going down. So in a table, you could tell really quickly if you're wise, because remember, Y is how much you have. So if your Y is going up, then it's positive. So if the Y's are getting bigger, then it's increasing. Sorry, I should have written increasing first. And then it's decreasing if the Y's are getting smaller. Then on a graph, it's important to remember that we always read graphs left to right, just like reading a book. So it's increasing where if, from left to right, the line starts down and starts to go up. But it's decreasing if from left to right it starts up, then goes down. Then we have y-intercept, which you've already learned in the past. But to remind you, the y-intercept in a situation is how much you start with. It's your starting amount. Right? Which, and I'm going to jump to the graph because that's the next easiest one for the y-intercept. On the graph, it's where it crosses the y-axis, which is why it's called the y-intercept, because intercept means cross. So, in a graph, it's where it crosses the y-axis. So if I were to draw a picture of that, and a random line right here where it crossed y, that is my y-intercept. Okay? Which means if it's on this y, if it's on the up and down line, it's not moving left or right at all. And if it's not moving left or right, that makes x be 0. Because x is how far left or right you're moving, and it's not, so x is 0. Which means, going back to the equation, to figure out the y-intercept, you plug in 0 for x and solve. When you have the equation, you'll just put a 0 where the x is and solve it, and you'll figure out the y, which would be your y-intercept. And then finally, the x-intercept. And I'm going to start with the graph and work backwards because it makes the most sense. So x-intercept, intercept means cross. So just like with the y-intercept, it's going to be where it crosses the x-axis. Which if I were to draw a picture of a graph, right here, that's the x-intercept. Because that's where it's crossing the x-axis. But what you notice is it's going left and right, but it's not going up and down. If it's staying on the x-axis, it's not going up and down. Which means y is how much you're going up and down, and if you're not, then that means y is 0. In a table, so you find it where y is 0. And in the equation, you plug in 0 for y this time, and solve for x. So in a situation, if the x-intercept is where y is 0, y is amount. So the x-intercept is where you have nothing. So the x-intercept is when you have nothing. And that's how you figure it out in a real life situation. Time to erase. So much math. Hopefully none of this was new. All right. So much. So I have 4 different situations, and I'm representing the 4 people in 4 different ways. I have a situation, and that's going to be about Jerry. I have an equation, that's about Maria. a graph that's about Joe, and if you look further down on your page, a table that's about Anna. So first we have to figure out all 4 key features for all 4 of them. Then we have to compare all their key features. Figure out and talk about their comparisons. So let's just start with figuring it out. So all the notes from the first page we're going to use in an example right now. So it says, here's the situation. Jerry and his friends are on the beach making sandcastles. But before they can begin building, they all agree that they want to start on flat land. In order to achieve this, they all pick a starting point that they have to make it flat first. Jerry picks a hole that's 5 inches deep. So Jerry goes and starts at a hole, and it's 5 inches deep, and he begins to fill it up at a rate of 1 inch every 3 seconds. And after 15 seconds for Jerry, the hole is filled and the land is flat. So let's figure out everything in a situation. So Jerry, his slope, his rate is 1 inch. So the amount is 1 divided by how much time is passing? 3 seconds. So if I put 1 divided by 3 in the calculator, I get 0.33. Is Jerry increasing or decreasing? Well, in his situation, he's at a hole and he's filling it up. So going up means he's increasing. His y-intercept, where did he start? For Jerry, when time was 0, his hole was down 5 because he was at a hole. And so it was 5 inches underground. And then, after 15 seconds, his hole is filled. So x-intercept is when your amount is 0, and amount is 0 in this situation is hitting flat land, like having no height and no depth. So in this situation, after 15 seconds is my time, he was at 0. His amount was 0. Right, so then I have to do it for Maria's equation. For Maria, she has an equation, and that's really easy for slope because it's just the one in front of x. So her slope is negative 3/4, which in a calculator is negative 0.75. Is she increasing or decreasing? Well, her equation, her slope is going down, meaning that she's decreasing. So she's removing dirt. Meaning she started at a pile of dirt. And she did because her y-intercept's a +6, meaning she started at time 0. She had 6 sand to get rid of. And then she's going down at this rate of 3 inches every 4 seconds, right? And then what about her x-intercept? When is her amount 0? So in this case, I have to make my y be 0, because that's the rule for x-intercept, is y is always 0 because your amount is 0. Negative 3/4, x plus 6. We solve for x by subtracting, that's 6. So negative 6 equals negative 3/4 x. You get rid of the denominator by timesing it away. So then I get negative 24 equals negative 3x divided by the negative 3 to find out that x would be 8. So for her, or for him, no, Maria, for her, after 8 seconds, my x was 8 for seconds, she was at flat land. All right, I'm going to erase this. So that I have room. I'm going to head over to Joe. Joe's this graph over here. So to figure out slope, first I have to find 2 points that cross perfectly. This one does, and this one. So between these 2 points, I'm going to make my triangle. It's down 1, 2, 3, so that's negative 3, and then it went over 1, 2, 3, 4. So his slope is down 3 over 4. He removed 3 inches in 4 seconds. Which, if I put into a calculator, that's negative 0.75. So he's decreasing because his slope is negative. His y-intercept, where did his graph cross y? That's right here. This point is 0 because it hasn't moved left or right, comma 3 because it went up 3. Meaning that he started with 3 inches of sand. Then his x-intercept, where it's crossing x, is right here. This x was over 4, so it's 4, comma, 0, because you're about 0, and the y is 0. Meaning it took him 4 seconds to get rid of all of his sand. And then finally, Anna's in the table. And so for Anna, for her slope, we have to calculate it. So I'm going to pick this to be x1, y1, this one to be x2, y2. So slope is y2, which is negative 1.5, minus y1, which is negative 2, over x2, which is 1, minus x1, which is 0. Negative 1.5 minus negative, which becomes plus 2, happens to be 0.5 over 1 minus 0 is 1. 0.5 divided by 1 is still just 0.5, which means each second she's getting rid of half of an inch of sand. This slope's positive, which means it's increasing. So she's not getting rid of the sand, she's adding the sand to her hole. So she's at a hole right now. So she's increasing. Her y-intercept, when x was 0, y was negative 2. So at time 0, she was down 2 inches. So her hole that she started at was 2 inches deep. Then her x-intercept is where y is 0. And that's over here. This is where y is 0. Which means it took her 4 seconds to hit flat land, to have no more dirt. Or no more hole. So we figured out the key features for all 4 people in all 4 situations. But the point of these notes isn't to figure them out, it's to be able to compare them. Because that's what they want you to be able to do on the test. So here's about the word compare. Compare means what's different. So if all of these people were adding dirt to their pile, we wouldn't compare increasing and decreasing because they would all be increasing. But in this situation, we do have some people increasing and some people decreasing. So your goal eventually is to know how to compare them yourself. I helped you by giving you questions. So all 4 people, Jerry, Maria, Joe, and Anna, were at the beach. They either started at a hole that they had to fill up, or they started at a pile of sand that they had to remove until it was flat. Use the key features to answer these questions. So if I just said compare the key features, you would have to come up with these questions by yourself. But let's talk about this. Who started at a hole? So if you're talking about where they started, that's their y-intercept. So when I think of the y-intercept in this situation, it's about who started at a hole or who started at a pile of sand. So anyone who started negative was at a hole. So both Jerry and Anna had negative y-intercepts. So I know this because of the negative y-intercept. And then so who started at the pile of sand? The people who had the positive y-intercept. So in that case, it would be Maria and Joe. So I could also ask, because some of them are positive, some of them are negative, but I could also ask between Jerry and Anna, who had the bigger hole? Well, Jerry started at negative 5 and Anna started at negative 2, so Jerry's hole was bigger. So Jerry has the bigger negative y-intercept. And between the 2 people at the pile, Maria and Joe, who had the biggest pile when they started? Well, Maria's was at 6 and Joe's was at 3. So Maria definitely had the bigger pile. I know that because she has the bigger positive y-intercept. So for all 4 of these questions, Those are ways I can ask and compare the y-intercept. Who started positive, who started negative, who had the bigger one both in the positive and negative, and in this situation, it's about holes in the sand. So I need to make sure I'm talking about the holes and the sand when I'm comparing them. I'm going to erase this so I can move on. Because next, there's ways to compare the slope. For example, I can ask who's moving the fastest. Because your slope is how much sand you're adding or taking away each second. So who's moving quicker, right? Well, if you look, Jerry's slope, once you make the decimal, was 0.33. Anna's was 0.5, but both Maria and Joe were negative 0.75. So they're tied for moving the fastest. They're both getting rid of dirt, but they're both doing it at a much faster rate than the two people who are filling up dirt. So both Maria and Joe are moving the fastest. And I know this because they have the biggest slopes. And then for the slowest between all four, it was Jerry that was moving at the slowest rate because 0.33 was the smallest of all the numbers. So Jerry is moving the slowest. I know that because he has the smallest slope. All right, and finally, to talk about how to compare the x-intercepts. Remember, the x-intercept was where they had no amount, meaning they had no sand, no hole or no pile, which means they're hitting flat. So in this case, you could say who hit flat first and who hit flat last. If you look at the x-intercepts, it took Jerry 15 seconds, Maria 8, but both Joe and Anna, it only took them 4 seconds. So they actually tied Joe and Anna because it only took them 4 seconds, and that was the fastest. And I know that because I'm looking at the x-intercepts. Because of the x-intercept. It's like the first one. 4 is the first one that hit 0. And the last one to hit 0, it took Jerry's 15 whole seconds. So I know because of Jerry's x-intercept that he hit flat last. So Jerry hit flat last because, and I know this because of the x-intercept. And now I've compared all the key features. And